Hello world, Lee here with Ruby Gold, and in this video we're going to be continuing our journey through the minds of the Ruby track on exorcism. As usual, we'll be choosing an exercise. I think in this video particularly we have another learning exercise, the savings account exercise, and we're going to go through there and try to solve it. This video is aimed at the beginner Rubyist who's sort of picking up the skills and trying to continue to learn. This exercise, we'll see what we get with it. In the description here, it says learning about floating point numbers by adding interest and savings accounts. It threw me off a little bit because I was trying to find it in this map. So I looked at like numbers and such, and it's not actually in any of these. It's down here in loops. So I found that a little bit curious. If we look at the layout here, it looks like we're just about done if you're following along with the series through with all of the learning exercises. So I suppose that means the difficulty will ramp up a little bit soon. I did try something a little bit different, and I took a peek at the exercise first. I wanted to see if I could notice any gotchas or not. I'm not sure if I succeeded. And by taking a precursor, taking a look in advance, I mean, I spent like 30 seconds scanning it. So we'll see how it goes. Common disclaimer, I will be making a lot of typos. This is what my keyboard layout currently looks like. If you know your QWERTY layout, right, to show you the difference. Basically, any of these bright keys are different from a standard QWERTY layout. So I will be making lots of typos. This is the third step in a 5-step switch from QWERTY to a different layout. I bring it up again, not really for the purpose primarily of the fact that I'm going to be making a lot of typos, but more about the fact that like you don't need to be concerned with switching your layout. QWERTY's fine. One of the principal programmers who taught me early on when I was in my teenage years, or possibly even before then, probably a teenager, was a hunt and peck typist. Didn't even know how to touch type, didn't know where the home keys were, what the home keys were, much less know, even care about them. 2 fingers, hunt and peck. And he was a perfectly capable, actually quite successful developer. So don't get caught up in these things, right? Don't get caught up in anything. Honestly, when you're learning programming, we're just here for a nice journey through. There's a lot more skills about thinking about problem solving and how to face the challenges that are more important than those things like being able to type well and being able to memorize all of the syntax and so on and so forth. We'll see. Occasionally I look things up in these videos, and we kind of make it up as we go. So jumping into the exercise here, savings account, we can take our initial scan of things. We see there's 3 methods, and you can probably guess there's going to be, essentially, we're going to implement these 3 methods. So an interest rate calculation, an annual balance update, and years before desired balance. So they are here. If we run the tests, we should get some failures. We always like to do this first. So we've got quite a few tests, 25. A lot of these will be knocked out in, one step at a time. So we've got some interesting information here. I have to apologize for previous videos. I've been very confused about this test layout because tests used to show in a separate tab on the top. Now they just sort of show in place here. I don't know that we get like the full test setup. I'm not sure that these have a lot of tests set up. Maybe those are stored separately, but we can at least see like the basic way that the test is set up. Often I've had video blindness, streaming blindness, where I've totally missed the fact that this is right in front of me, but it's here. So yeah, that's the precursor. Let's jump into it. So minimal first interest rate. Tiny first. This is kind of interesting. I'm just looking at these test names, test 1, 2, 3, and so forth. So we can see that there's a handful of tests here that have first interest rate. And then there's a couple of second interest rates and a couple of third interest rates. And then we get into negatives. So it looks like possibly the first 13 tests or so follow this pattern, and we'll probably be solving all of them with our first method here. So the first thing we can do is let's change the error to something a little bit more useful, right? So instead of raising a runtime error, let's raise an actual error. So assert in delta. And here's another thing. The test itself is like assert in delta. So it's actually, if you look this up, it's trying to find, I believe, with an interest rate of 5, well, that's some parameter. Right, here's a second parameter. And essentially, we're looking for a difference of that amount. So basically, it's sort of like saying that this and this need to be practically equal. I'm not entirely sure why we're using testing methods that they're not fully equal, but maybe there's a reason for that. Yeah, so, but let's see if we can sort of make it through here. So nil can't be coerced into float. I think what would happen is I can get a different error if I put just a float in here, right? So here we can see that like the value 0.5, the absolute value, or the absolute value of the difference, right? I think that's how that's read. I think this is like in mathematics, the absolute value, which in this case is that, needs to be less than or equal to, right? So we can sort of cheat here a little bit and probably pass this first test. Couple of tests really. So we can see what's happening, and that gives us some information. It looks like we know what we're doing correctly. Self-interest rate. So some other information it gives us here is like, okay, so minimal first interest rate, tiny first interest rate, maximal first interest rate. So so minimal first interest rate is 0. Sorry, on a 0 balance. And on a tiny first interest rate. So on a very tiny balance and on a very large balance. So this 0.5 here, thinking about the product, the specific domain of this company, let's, basically probably writing this for a bank or something, we can sort of figure out here that there's an interest rate of 0.5% on a savings account. Well, so, right, is that 0.5%? That's, so, okay. Take a step back here. Right, bank interest rates are not like they used to be. Yeah, so 0.5%. Now, it's a little strange to me that we're representing it this way as opposed to like a fraction of 100 or something. But I mean, there's probably reasons for that, and I'm not saying this is incorrect. It's the way that we're going here. But we know that we're passing these 3 tests in a fraudulent sort of way, right? And I'm kind of curious, if we did something that looks like this, would that still pass? it does. Because remember, we actually have that ability to go not exact. So that's interesting to keep in mind, especially with floating point math, which is really scary when you're working with money, right? And so we can see that sort of plays out here. Where things are a little strange, but let's go back and try to figure out what's actually going on here. So here I am going to pay attention to this little bit of the instructions, and essentially what we're seeing is that, so this method essentially is intended to give us back the interest rate based on the specific balance given to it. Right, that's the way that I'm viewing this. So yeah, right, to calculate the interest rate based on the specified balance. Okay, yep, so that's consistent. These amounts being passed in are between 0 and 1,000. And that's effectively as close as you can get. I mean, you could extend this out indefinitely, but that would be a little silly. And also, like, in dollars and cents, you're not really going to have a balance like that. So I mentioned that, like, floating point, like, this is to me a little scary, the fact that we're doing dollars and cents like this. In the real world, you probably don't want to do this. Typically, you're going to be doing integers and manipulating those. So you're going to be like, what is your smallest unit? Cents, right? Dollars and cents. This is USD. So whatever your smallest unit is in your denomination, you're going to be storing that as like the integers because floating point is pretty dicey. But that's not important for this exercise. For this exercise, we're going to stick with, the way that this is written. So, but keep that in mind, especially if you're a new programmer doing one of your first applications. Avoid storing money as floats or decimals or any kind of such thing. Try to stick with integers of the smallest unit possible. So anyway, yeah. So essentially, what this is saying here is, let's wrap this in a case. And the case would be our balance, right? So where is it when? Whoops, I always forget that button won't do what I intend for it to do. So if I wrote this correctly, which I probably didn't, we probably need to do something like balance less than 1,000. It's like I always get my syntax wrong. Do we have dash running here? Over on my other screen. That's good enough. Case, right? So does that mean okay, so we can do it this way. right? All right, so we translated this into a case method. So technically we're missing an edge case here. We'll handle that probably later, but if you pay attention to what the instructions said, these are all, well, so this is a non-negative balance. So we'll have to think about how to do negative balances in a moment. But let's see if we can translate the rest of these. So here is, we can see we've got a test for our $1,000, for our $1,000 and just over $499. So it looks like our next range is probably $5,000. And I'm assuming that those are going to have different interest rates, right? So we could reconstruct this from the tests at this point. I think we have a pretty fair understanding of what the tests are doing. We're sort of testing the bounds of our ranges, but it might be a little bit easier just to look at the instructions here that our product manager has gathered for us and presented to us very helpfully. So do we recall what the single line case expressions, how we write those? Let's see. So it's when then format. Yeah, I don't know if that's going to be optimal or not, but let's see if we can reduce the number of lines here and make things slightly more legible. All right, so our next thing would be basically fewer than 5,000, right? So we're going to return 1.621 because that makes sense, how the bank comes up with those numbers. All right, so we did pass more, and then it looks like we exceed the threshold, so we're going to go over, so a positive balance greater than or equal to 5,000. So yeah. Well, I guess it's equal to or greater than 5,000. 2.475. Yeah. So I would like to have done this example here with the variable using balance, but I believe we're unable to do that because we're doing a comparison inside of our individual cases. So that's why we end up doing, and here's my like ongoing problem with the indentation of case statements. This is like considered the optimal, but it feels off. Okay, and then we have a negative balance. So technically, if our balance is less than 0, uh, 3, 2, 1, 3. Okay, so that's interesting. For a negative balance, well, I guess that makes sense. You're going to owe money. So essentially, you're going to pay negative interest and at a pretty high rate. So at this bank, make sure you do not carry a negative balance, or you're going to owe a lot of money. So we could leave it like this. We could change and make this last one maybe an else, but I kind of like the clarity. Do I like the clarity? Let's look at, well, first of all, let's see what tests pass. So yeah, 13 tests pass. I think that's the number we expected. Let's look at maybe else here. And I think the format is we don't need then. Okay, so here's the alternative. We can write it like this because it's basically greater than or equal to 5,000. But sometimes it's useful to do this in this instance. I feel like something is lost. So even though we like to reduce code as much as we can, right? Obviously, like, this is less code, but here I feel like the greater than or equal to 5,000 is kind of important. And it's meaningful, and this is easier to look at and say, like, what's going to happen. So I think I'm going to stick with it like this. Run these tests one more time. Make sure they're still passing. Okay. And so, yeah, so I think that's good. We can see that our next test is, in fact, calling please implement this method. So we've got, let's see, a couple. Let's jump down here. Yep, so the next handful, what is that, 6 or so? 15 through 21 should all be the next method. And as we can sort of gather, it seems like what we're going to be doing is essentially passing in a balance and determining what the balance should be after 1 year. So passing in a balance, after 1 year, it should earn so much. Passing in a negative balance and how much they will owe, that's a lot of money real fast. Passing in a large balance and calculating how much. Yep, so pretty simple here. Change our error message. And yep, okay, so more of these, right? By default, it's nil. Nil can't be coerced into integer. Interesting. Here, it's actually trying to return an integer. Oh, I guess that's just the way that something to Ruby is doing. So we still want to return a float. Yeah. Which, I mean, what is 75,375, right? Do you actually have, like, in your balance, do you have 375? How does, where does that go? Like, if you cash out your account, the bank's not going to give you 375. Ooh. Sneeze out of nowhere. Ooh. All right. So what are we doing here, right? Essentially, if we're passing in a balance, we're going to basically get yes, and so we're using a module. So In this case, it's not an instance. This is not a class, so there's not an instance here. So what we cannot do is we can't do balance, right? How would you get this 1 point? So math is not my strong suit. Interest rate balance. Right. So like we might be tempted to write something like this. So balance times interest rate balance, right? So that should give us the number that we're adding onto the balance, right? So the earned interest interesting. Make note of that. Earned interest. We'll make note of that and clean that up in a minute. Might be something there. Feel free to pause the video and figure out where I'm going with that in advance. So let's see what happens. It should probably blow up. Things are going to blow up. We should not pass. Well, we passed one more test, I guess, which was a negative balance of $0. Well, $0 balance did not earn any interest. So small positive balance here. This does blow up. What about like an average balance? So $1,000 should earn. Oh, I see. Okay. So $1,000 should earn essentially $16.21. That is this amount, 1.621. So I think we had our math wrong because this is 1.621%. No, that's still going to be wrong. And here we don't even pass any tests, right? So where was that average balance? So let's put that back. We were actually, so here, essentially what we got was the expected value and the value we actually got. So we're off by a factor of 10, right? So we got $1.621. What we needed was $16.21. So these are percentages, and so technically, let's see, this is going to be totally wrong. Oh, I think I missed it. I was trying to like do an extra. Yeah, I was trying to type an extra parentheses and I totally missed. So what am I doing here? I'm trying to see like what my numbers are. Unfortunately, these are formatted. Ooh, way off. So I thought we were, let's go back to this and see what we did wrong, because it seemed like this was pretty close to right. Okay, so we got this amount here, which, so if I take off the addition and I just start with balance times interest rate balance. This is very confusing. Okay, so here, essentially what we can see is this gives us the actual increase, right? So in theory, if we take this, and I've got a lot of parentheses here, right? And we go back to my original idea, this represents the actual increase. So if you recall, if we take this out, we ended up with an amount that was, so in this case, it was just a little too high. Because we essentially were getting 1621. But because these are percentages, if we divide this by 100, we actually get the correct amounts. Because again, inside of here is the amount of interest that is earned. So coming back to this note I left to myself, right? We can call this earned interest. And get rid of my note here because I don't need it anymore. This is probably going to be private method. So I'm going to do this slowly. We're going to see if we get errors from stuff. Let's probably need to pass in something. So okay, and then we take this one and drop it here. Let's see what happens if everything blows up. Yeah, so it blows up, and so the reason for that, and like I said, we're going to take it slowly and just demonstrate some stuff here. So this is the way, if you're following along and you're just learning Ruby, we've done everything in classes so far. And so this is like how we would have written the instance method for the class. But if you follow the instructions, it talks about how we're doing modules and not classes here. So there's no actual instance, so an instance method doesn't make sense. What we need is basically a module. What do they call it here? Yeah, well, Right. It's a class. So don't get too confused by that. It's a class method. Essentially, in these beginning days, you can probably just sort of look at that and say, well, okay, that means I need self on the beginning of it. So let's see, because, right, undefined method, earned interest for the module. So if we do this, let's see if it's any better. And yay, it works. Okay. So what I like about this is we don't have just like this random method here. We have a named thing, and that to me is useful to have a named thing because we can actually do something with it. Now you might want to take this one step further and give yourself an adder reader balance. So you would be like, okay, so we can do an adder reader of a balance and we could initialize it, but you remember this is a module and not a class. So the concept of initializing doesn't actually exist. Right? Right, so like stuff like this won't work for reasons, right? Because like there's no, we're not, so this is, I'm trying to like maybe go a little too heavy-handed here, but like we can't do this in a module. So savings account is the module, like we're calling this. This is a module. It's a collection of things. It's a named like component kind of a thing that's available to us that we can pull in and use in our code, right? So we're writing this and it's the only thing we're using, but like in the theory is that we would have some other code that we're trying to do and we'd pull in this module and utilize the module. And so we would have these methods like annual balance update and so forth. And we would use it inside of our other thing, probably a class. But the module itself is not instantiated. We don't initialize it. There's no instance created. So these tricks that we like to do elsewhere, we can't do. So kind of belaboring the point, but I just wanted to show like we can't do this, right? So this does not exist. Similarly, how else would we do this, right? Whoops. That was really took me far away from where I wanted to be. Right, so we can't do stuff like this because these don't exist. Yeah, so your method, the error here is essentially undefined method this for nil. So it's trying to do this comparison because we passed in something that is nil because these don't exist. Right, okay, so let's see if we can undo enough of this to get back to a working state. Okay, that's probably a working state. Run the tests again. Yes, awesome. Here we go. Cool. Yay. All right. So we've got a balance. We have a named thing now. So this is something extra that we can use, and it avoids us having all this math in here when what we're really trying to say is that it's the balance plus the earned interest. And so our next thing is basically we're going to be trying, so here we use assert equal. Interesting. So essentially, the idea is, so we pass in a current balance and a desired balance, and we're saying that how long would it take to go from $100 to $125.80? And the expectation is 47 years. That's a long time to wait for $25. A long time to just have an account sitting there with $100 in it, earning 0.5% interest rate. All right, so here we are getting into the sort of looping of this exercise. And so again, that fails. Just sort of like sanity check. If we want to pass test 22, we can pass in 47. If we want to pass test 23, we can pass in 6. Obviously, we're cheating. This is not effective. So essentially what we're looking for is to get something like this with some pseudocode. So maybe we're going to have an iterator, right? So an iterator, it's going to probably start at 0. Because like if the current balance is the desired balance, right? So let's be a little explicit here, right? So, oh, that didn't work. So number of years. So we're going to return the number of years if current balance is greater than, whoops, or equal to desired. Yeah, we can do this. We can do this. So probably this is going to fail for any number of reasons, mostly because the tests don't pass, because none of them should pass, right? Unless we do something like, well, they're not going to pass. So if we do this, yeah, so before that, if we just do, oops, let me keep that on. If we just do this, we stop returning nil and we return actual. But we probably are going to do something like this. I'm not sure this is actually how we're going to write this, but let's start here and see if it works for us. Just sort of like thinking through the components of what this code needs to do. So let's think about the positive balances first. And I see how they're doing. Yeah, I can see how the exercise probably wants you to think about this as a loop. So kind of like an inverse of this. Right, so we start our iterator outside of the loop. And I don't do a lot of loops. And I think the instructions say something about, like, we don't really do a lot of loops. We tend to use enumeration. But let's see what happens here. Yeah, their iterator is just counter. I like the clarity of a named thing. Whether we do this, it could be really either or. Let's do heads or tails. Flip a coin. Flip coin, tails. All right, so cool. This one is tails, so we're going to do an until, right? So what is like the until version of this? So until the current balance is greater than or equal to the desired balance. So in this case, I took off the return because it looks like I'm going to be doing like I'm just going to return the last thing. So I don't need to explicitly say return. So here, I guess we're going to be doing two things. We're going to be, counter plus 1 equals to 1. So number of years plus equal 1. And we basically need to find so our current balance needs to get updated like this. In theory. Let's see what happens. So our test fails, undefined local variable or method balance. Okay. So we don't have balance here because, again, this is not an instance. It's not a class. It's a module. So the thing we're operating on is current balance. Let's see what happens with that. Okay, and it looks like that succeeded in passing all of the other tests, including our negative tests. Kind of curious about the negative balances, but I'm not going to think that through right now. This method here is kind of long, and I don't love it. So we might want to think about ways that we could sort of enhance it. And for that, probably we might want to look at some other solutions and see if we can get an idea. You're going to write a lot of code like this, probably. I don't like code like this, but you're going to write a lot of code like this. You're going to set an iterator. You're going to do something in a loop. And then you're going to return a value. In this case, it is specifically the iterator that we are returning. If this was a while or an until, it would probably be the exact same. we would just have to, you know, flip some cases or something, flip some values. All right, so run this again. Yeah, we'll just so no immediate feedback. That means we're good from the perspective of automated feedback. And we can take a look at some community solutions. I'm thinking because we named this thing earned interest, we're not going to match many other solutions. I always forget. This is another thing I need to look up and memorize. Where is that? Is it because I didn't? I'm always looking for the window that shows me similar, like the submission. Who else did my submission? But I don't know if this is because I have a unique submission. Or not. So anyway, it's probably not too important to go through those. Sort by fewest lines. What do they got? 10 lines of code? Well, yeah, I mean, face palm. Oh, don't do this. You can't read that. That's not good. This is probably not too helpful to look at fewest lines. Maybe some of these are going to be elegant enough. You know, they're doing things. Oh, they're doing ranges. That's not terrible. I don't hate that. I don't love it, but I don't hate it. Yeah, that person used an enumerator. Let's look at some most common submissions. 17. So it's not a huge number of repeats. Yeah. So, okay. So this is the guard clause method approach design. So instead of a case statement, this person basically, if the balance is less than 0, return this. So it only needs to like evaluate the number of these, and then you could actually skip the return on the final one. It only needs to evaluate these up until it finds a match, and then it, you know, ejects out of the method. I like return guard clauses. I like to write code like this a lot. The alignment here. So wait, did people copy paste? Why is this, if there's, I don't know if the submissions look at spacing or not. Oh, interesting. Interesting. Yeah, absolutely. So that's kind of interesting to dig through their iterations. But if this comes up and it's with the spacing, did people copy paste? I don't know. But yeah, so it only evaluates until it finds a match and then ejects out. I like to write guard clauses. I like to use them in my code. I'm very keen on them. For this, I think I prefer the case method. So I'm not going to be taking any pointers here. This is a convention. You actually saw this if you looked in the way the tests were written. This is a Ruby thing. You can, so essentially it takes the place of commas. If you want to make it clear, you can add underscores. And that's helpful for like the, 100,000, million, 5 million, 500 million, for like bigger numbers. This is basically exactly what we had. Fewer parentheses, that's fine. Bam, same thing. The big difference is I put my iterator first. conventionally, I think you're taught to do your iterator like as the last thing, but it in this here, it doesn't matter. And if else if, that's fine. Here, there's 2 lines. So yeah, this would be the alternative, you could say. So I created a method that is earned interest. It's technically like 1 year of earned interest, not total earned interest. It's fine. I'm not going to change it. But this person, so this is a pattern I don't like personally. They did a variable that has a single use. And so it's not really the way we did it in our solution is more of a pure object oriented way. It's an object and the object has methods that you call, right? So I guess technically it's not an object or, well, there's not an object made, but like object oriented programming, it still works. Little, just, little fine point there, nitpicking. This, however, is you create a variable for one-time use, and I don't like that. It's probably better, arguably, than having this whole thing. So this is, 1 plus. That's the thing I was trying to do. Math isn't my strong suit. That would be the alternative. Maybe we'll play around with that. So it's probably better than having the whole thing spelled out here and having an extra long line. But again, single use variables like this, I don't like. It's just, to me, it's unnecessary. It might be inconsequential from like a garbage collection perspective, but you are introducing a variable and you're using it one time, and like you're creating an extra line of code for like almost no practical reason. And then here, new balance equals current balance. I don't understand why. They have this extra line declaring a variable for, I don't know why they did that. Let's see. Highest rep user. Let's see what this person does. So this one's going to be pretty different. Yeah, that's fine. Here their case statement is broken out on multiple lines. They have an argument error if the balance is less than or equal to 0, which that's pretty good. This exercise doesn't require anything like that, but that's probably good practice. And yeah, I mean, there's probably no real getting away from this. So this is interesting. Let's see. So they essentially split their balance update to have similar to what we did, they have an annual interest, which is probably a better name than our earned interest. So annual interest, that's probably better. And then they call that again. They call it explicitly with self. We don't really need to do that. So they did the same thing with slightly different syntax and methodology and fdiv. Float division, I guess. I've never used that. So yeah, and then how did they do? So compound is how they do this. Okay. I actually, so this is a little bit more in line with like an enumeration method of sorts, but not really. So basically they turn this into a single line, the actual years before desired balance. And it starts off on year 1. So their case doesn't really handle if you're 0 years. But I think that would be something you have to understand. If you're already at the balance, is that considered 1 year or 0 years? So something we would have to know. So they're passing it into something else that doesn't use a loop, which it uses an if else statement, which is kind of interesting. And it's recursive. So I guess you would say this is functional programming in a sense. It's an interesting approach. It's not like super Ruby-ish, but I kind of like it for its own merits. I'm wondering if this person like came here to try different paradigms in Ruby. Let's look at this one. Yeah, same thing. We already looked at that. Who else? What is this? I don't know. This will be the last one. Did we already look at this one? No. Yeah. Okay. So there's not much we sort of get away with. I think the only real thing is I did like the name here better of annual interest, but I kind of want it to be annual earned interest. Maybe that's too long of a name. Maybe I should just do annual interest, but I kind of like that better. So everyone did while. We did a dice roll to do until. It's fine. Yeah, I think this is fair. This is pretty good. It's going to be difficult to clean this up. Probably the amount of time to try and come up with something is probably not going to end up giving us something that's better anyway. So I'm happy with this. I think this is a good solution. I'm going to submit it one more time. I think we found a nice happy path to a solution for this problem. We're going to do this, and I guess that's good. It looks like things changed and we no longer... here it is. I'm looking for the mark as complete. Yep. So I think this is good. We found a nice happy path through the exercise. I think our solution is fine. It's a solution that I would be happy with, generally speaking, if you submitted it and I was doing code review. I like it. I think it's pretty good overall. I'm going to mark this complete and share my iterations. Oh, I probably have to do that before it can show me what similar iterations are. Yeah, unlocked some new stuff. Let's see. Here we can see well, I don't think we're going to have anyone else with the matching. Yeah, nobody else is going to match us. Once I upload this video, you might be watching this because it's in Dig Deeper. It seems like maybe Dig Deeper is available before you solve it. If you are in, there's like when you start a track on Exercism, there's like two different modes. There's like a learning and a practice mode. And I think if you're in practice, you'll see Dig Deeper before you solve it. But if you're in learning, I think you have to solve it first. I could be wrong about that, but you might be watching this video on Exercism, in which case it's already in Dig Deeper. If you're watching this on YouTube, it might not have been approved on Exercism yet. There's usually a 1 to 2 week delay for approval, but you can certainly follow along and solve this. And yeah, so in the comments, let me know if you solved this, if this helped. Especially if you're watching on YouTube, in the comments. Let me know if it helped. And feel free to, share a link to, or I guess maybe you can't do a link, but you can give me your username or something. We could take a look at some other exercises, other solutions. Certainly I'd love to see if anyone watching these videos has come up with any cool, clever improvements or differences between the way that I solve it. But yeah, hope you found something useful here. I appreciate you taking the time to watch these videos and go through these exercises with me. I love doing this, and I'm going to keep going. So yeah, that's about it. So remember, there's gold in them there rubies.